Hello everyone, my name is Jacob Jansons, the Robotics Coordinator of the Boys and Girls Club of Fitchburg, Leominster, and Gardner, and today I will be talking about computer vision. So this is actually a topic that stems pretty directly from the sensors and the video about autonomous cars, self-driving cars that came out yesterday, or on Tuesday. And I wanted to delve into this topic because it does apply to both of those things. So, what is computer vision? At the basic level, it's training computers to do what we humans can do with our sight. And it uses these very complicated algorithms in the software to detect objects, edges, colors, as well as data about the things it's detected, like the size of it, relative in the picture, the number of them, etc., etc. Where this connects to sensors is that this is another type of sensor that a lot of self-driving cars use. In addition to radar, ultrasonic systems, and other various types of sensors, these self-driving cars also use vision processing, computer vision processing, to understand the world around it and figure out landmarks, detect stoplights, all of these things that a human would know how to process, but a computer has no idea what this is. It's just a picture. It doesn't even really know what the picture is of unless you tell it, and really it's just a bunch of pixels as far as the computer's concerned. It's a giant list of numbers on how to make this picture. So computer vision gives meaning to those digital images in the computer, and is able to make something out of it. So, quick little tidbit: this all goes all the way back to the 1960s. This type of technology, university researchers looking into AI realized that a vision system is a kind of key component to the science fiction interpretation of artificial intelligence. How do we get a humanoid or a synthetic humanoid? Number one on people's mind is vision, because that is a primary sensor for us humans, because sight is a very powerful element to our survival, to our daily lives, and it's kind of, if you can leverage the amount of processing that the human brain can do with sight, how many things it takes in at every instant, you can create a synthetic life form, synthetic intelligence that is able to process all of what it's seeing, and combined with its other sensors, figure out its environment. So what can we do with this computer vision? Well, one of the first ones is detecting colors. And we actually use this feature a lot in our competition robotics program in the Boys and Girls Club Teen Center for first robotics competition. They usually have what are called vision targets on the field, and these are retroreflective. Now, retroreflective means that the light coming towards it, instead of being bounced off at the exact opposite angle like a mirror, if you've ever gone up to a regular mirror and shined a flashlight at it, it comes off at the opposite angle of which the flashlight was shown onto the mirror. Retroreflective sends it directly back, so exactly the direction it came. This, if you want to see this out in the real world, a lot of stop signs and a lot of the road signs you see are retroreflective. That's why you can see them so easily at night, because when your car's headlights are shining into the night, it's bouncing directly back at you, or back at the source, which in general is slightly above where you are, slightly below, so you can still see it. So, going back to how we use this in competition robotics, they have the retroreflective vision targets. And these are specified areas where these targets are, with a specified shape, size, and height, all these dimensions, and what we generally do is set up a green LED ring that sends out a bright green LED light. And that, on the retroreflective, bounces straight back into our camera. And then we use the vision processing, the computer vision, to take what it's seeing and figure out a few things about it. So we can figure out where we are relative to the vision target. In this most recent season, the 2020 season, we used it to track the goal, because it was around the bottom of the goal. And when we were lined up with the vision target, we knew we were on target and could fire or shoot our balls at it. This is a very common thing for us in the competition robotics world. But there are also, more advanced systems that are able to detect color in other ways. So moving on to detecting objects. So right here you're seeing a demonstration from a all-in-one computer vision system called the PixieCam. And what this system does is it is able to track each individual instance of a colored ball and know where it is on the screen and follow it. So you're seeing as the researcher drops the balls, the computer vision system is tracking all of them with the boxes, so it knows where each one is and can track several different blue balls. Like you see there's one here, and one here. It tracking all of them. So this is combined object tracking by following the shape as well as following the color, and this system can do that, and it's able to dynamically assess which one is which and able to follow it on the screen and know where it is and be able to, as a programmer, you can use that information to do things like move the camera around to follow it, or like we do in competition robotics, know where you are so you can adjust or make changes to get where you want to be. And another big thing for it, and I think this is actually the linchpin of the future of this technology, is detecting edges. So what you're seeing on the screen here is a normal digital picture, and then on the right is the edge detection algorithm's output. So every edge the algorithm detects, it draws a line. So this is the ways the computer can analyze an image to start figuring it out. And we humans can tell the system, look, wherever you see an edge, there's likely a change of depth or some contour that's not flat. And you can leverage this into being able to correctly identify how far away things are. For example, if you give the software, the width of this girl's eye, based on the depth, if you know the size of the trees, you could figure out how far away the trees are in this image. All with one snap of your fingers for us, and hundreds of millions of calculations for a computer. So what's the future of this technology? So even with today's technologies, computer vision systems can actually create a 3D reconstruction of a space using multiple images. So if you've ever seen Star Trek Into Darkness, in that movie they have kind of a cool technology where they're able to scroll through and kind of fly through an image. That is already happening today. It's able to take multiple points of view and reconcile the differences to create an illusion of 3D. You can also see this in Google Maps. On Google Street View often does this as well. There's often a little bit of manipulation so you can create this kind of 3D effect with multiple images. And then another big thing is that AI systems are starting to be trained. So these deep learning networks, they call them, that are able to leverage computer vision to do things. So identifying objects, for for an object detection in a processing plant, detecting faces. Facial recognition technology is huge and is a hot button subject on the security side of things. We may investigate that one later. And another big one is like defects in food. Like in a lot of these food factories, they have machines that shoot a puff of air at a piece of, like potato chip that's overburnt, and it'll knock it out of the system so it doesn't go into your chip bag. It's similar technology to what will be going forward. And this is the future of this computer vision. We are at the beginning of it because, like I talked about on Friday, or last Thursday, we're now in the golden age of computing where computers have never been faster, and they're only getting faster by the day, able to handle multiple millions of calculations per second. Now we have the power to rake over these images, thousands of times a second, take hundreds of images per second and analyze them in the same amount of time it takes to get the next image, to rapidly do things. Like I said, there is a, very hotly debated security component to this with facial recognition. So, in closing, I just want to bring your attention to this because this is a great technology that I think will be used in the future. The question is, how will it be used? I've talked to you about a couple of the common applications that are, seeing the world today. Let us know what you think might, happen with this kind of technology. Are we going to have a computer vision revolution where a lot of times in factories humans are used to detect defects in food, defects in machinery? Will robots be able to do it with computer vision? I think that is one of the great things to think about with this technology. So I want to thank you for watching today's video. I've been Jacob Jansen, the Robotics Coordinator for the Boys and Girls Club of Fitchburg and Leominster. Thank you so much for watching. Have a great day.